Norway's electric plane. Norwegian flyers may be traveling on aircraft like this within the next decade. According to Norwegian government information, the Alpha Electro G2 aircraft has a range of 170 kilometers and can fly for up to 1 hour. Manufacturer Pipistrel says the aircraft's motor has power of around 50 kilowatts with a 21 kilowatt per hour battery. This is small compared to batteries used by electric cars. Variants of the Tesla Model X electric car use the 75 and 100 kilowatt per hour batteries. Pipistrel says the aircraft can be recharged quickly at customized charging stations. The plane was tested this month at Oslo airport. Carrying 2 passengers, it weighed 570 kilograms and was airborne for several minutes. Reuters reports the passengers described the experience as cramped, but quieter than a normal aircraft. The country plans to operate domestic flights electric by 2025, with a view to having all electrically powered come 2040. Electrified.
World's first all-electric autonomous container ship. Hey, where's the captain? Norwegian company Yara and maritime technology firm Kongsberg are teaming up to build the world's first all-electric autonomous container ship. The state-of-the-art ship will transport chemicals and fertilizers from a Yara production plant to nearby towns. The plan is for the boat to first be operated by a crew in 2018, before transitioning into remote operations by 2019, and then fully autonomous by 2020. By transitioning to an all-electric shipping pathway, Yara can cut down 40,000 truck deliveries in a year, which translates into reductions in nitrogen oxide and carbon dioxide emissions. Moving transport to an electric ship will also help improve road safety while reducing noise and dust pollution. Israel is going electric. Israeli transit service Dan Bus Company is set to invest over $2.2 million in technology that turns regular roads into an electric power source. Electric buses in Tel Aviv currently need to be charged via cable at departure stations, but this could soon be unnecessary. Electroad has developed technology that powers vehicles from the road while driving, using conduction coils to wirelessly charge them through magnetic induction. With this innovation, there is no need for batteries or cable charging. It also boasts zero emissions, high efficiency, and low cost. The startup will be focusing on public transportation and will begin with laying larger coils underneath designated lanes to power the buses traversing the road daily. Eventually, Electroad says it may even be possible to share energy between vehicles.
World's first electrified road for charging moving vehicles. Okay, that's pretty cool. The world's first electrified road that recharges batteries of moving vehicles driving on it has opened in Sweden. Around 2 kilometers of electric rail has been embedded in a public road close to Stockholm. The system transfers electricity from the installed underground rail to the vehicle above through a flexible arm that connects to the charging vehicle. The electrified road is split up into 50-meter sections. Individual sections are only powered when a car or truck is overhead. When the vehicle drives off the rails, the system calculates the energy consumption and debits the driver. At a cost of around €1 million per kilometer, the cost to electrify roads is 50 times lower than required to build a city tram line.
Harvesting energy from the sea. Japanese researchers have come up with special technology that can not only capture energy from waves, but also help protect coastlines. A team from Okinawa plans to set up energy harvesting turbines near tetrapods, which are concrete structures placed along the shore to weaken the force of incoming waves and prevent erosion. The turbine has 5 flexible blades modeled after dolphin fins. It's supported by a stem that's anchored to the seafloor with mooring cables, which, like the blades, is flexible and can bend under pressure. Inside the turbine head is a magnet electric generator, which transforms wave energy into electricity. The electricity is sent back to the shore via cables to feed into the grid. Using turbines on just 1% of Japan's coastline can generate roughly 10 gigawatts of energy, equivalent to about 10 nuclear power plants. Apart from tetrapods, the turbines can also harness electricity near coral reefs. They're built to be safe for marine life, with blade speed carefully calibrated so that any animals caught in them can escape unharmed. The team is currently preparing to install 2 half-scale model turbines that will power LEDs as part of a commercial demonstration. Bitcoin's power needs are getting crazy. The power needs for Bitcoin mining are set to get a little nuts. According to research published in the journal Joule, Bitcoin's electricity needs may reach as high as 0.5% of the world's total by the end of 2018 and 5% within a few years. The same amount of electricity used in one Bitcoin transaction could power the average Dutch household for a month. The study says the Bitcoin network currently consumes 2.55 gigawatts of electricity, nearly the same as Ireland. By the end of 2018, the study predicts that number to rise to 7.8 gigawatts. Computers in a decentralized Bitcoin network calculating transactions compete every 10 minutes to create the next block of transactions in the chain. Known as Bitcoin mining, this process sees the winning hardware get 12.5 Bitcoins, or around 100,000 US dollars. However, as Bitcoin calculations become more difficult to solve, people employing more computational power have a higher chance of winning. The problem with this, study author Alex de Vries explained to Gizmodo, is that the process motivates participants in the network to use more hardware and, as a result, more power. Writing on the research, Popular Mechanics notes that Bitcoin could, quote, single-handedly set back clean energy for decades. The publication writes that this level of Bitcoin electricity needs would require new fossil fuel burning power plants.
Flying drone taxi takes off. Drones are everywhere these days, and soon, flying drone taxis might be too. At the end of January, Airbus Silicon Valley carried out their first successful test of their autonomous aircraft. The all-electric drone flew at a height of 16 feet for 53 seconds by itself. According to Engadget, Airbus hopes to create a network of autonomous flying drones. The Verge reports that Airbus aims to create a production-ready drone by 2020. Would you ride one?